So now we have injected our disinfectant into the water system. Now we need to check water treatment system. So a routine practice would be just, listening to the pump, to the injector, to see if it is clicking and assuming, the treatment system is working well. But strategic practice is to test the disinfectant residuals at the beginning of the water line and end of the water line inside the barn and measure the chemical residuals like chlorine residuals or hydrogen peroxide residuals or chlorine dioxide residuals, measure it and document it, because this documentation is really important to see if our water line is clean or not. And overall, these data, is vital for our future plans. So now let's have a look and see what those residuals should be. This is a really important part of this presentation. So if you are using hydrogen peroxide to disinfect your water, you can use hydrogen peroxide test strips, which can measure a range of 0 to 400 ppm, or you can use titration type hydrogen peroxide test kit that can measure up to 1000 ppm hydrogen peroxide if you want. But overall, keep in mind that the target end of line concentration of hydrogen peroxide should be 50 to 75 ppm at the normal situation. But if you are, fighting against disease outbreak like avian influenza, then you can go up to 150 ppm hydrogen peroxide residuals at the end of your water line. It is really important. And keep in mind, birds can tolerate up to 200 ppm hydrogen peroxide in water as well. But because of some technical difficulties in measuring the hydrogen peroxide residuals, we wouldn't go beyond 150 ppm. As I said, during disease outbreak, you can go up to 150 ppm hydrogen peroxide residuals at the end of the water line. But during, normal situation, when there is no disease outbreak, having, 50 to 75 ppm hydrogen peroxide residuals at the end of the water line should be sufficient. Now, the question is, we said you need to reach these concentrations at the end of the water lines. Then what should be the starting point? What should be the starting point in the beginning of the water line? So now we need to find the critical points in a drinker line. How? By using an inspection camera like this and oxidizer residual test strips together, which is hydrogen peroxide test strips, right? So you need to inject hydrogen peroxide into the water line and then go 1 meter, 2 meters down the water line and measure the residuals of hydrogen peroxide. See what number you are seeing. For example, let's say it is, 75 ppm. And then go a few meters down the line and measure the residuals again. Trigger the nipple drinker and get a sample and then use these test strips to measure the residuals. So then you may see, okay, at some point, these residuals drop a lot. For example, let's say it was about 70 to 75 ppm, and all of a sudden, after a few meters, it dropped to, I don't know, 20 ppm. So it shows that during that section of waterline, there is a contamination, like biofilm or any sediments, or overall the water is dirty in that section. That's why it eats up the uh, hydrogen peroxide. So overall, in that case, we need to use like T or Y uh, pieces to put in the water line, and wherever we see there is contamination, then we can insert, this inspection camera tube and go through the line, and we can see what's going on the screen of the camera. If there is any blockage, any biofilm, and then we can clean it up from that point. So it's a method to see, inside the water line. Because at the beginning, we don't have any idea what's going on in the water line because it's a hidden system, right? But when you are measuring the residuals of your disinfectant, down the road, you are seeing, its pattern. If it is dropping, if the concentration of residuals is dropping or not. If it is, it shows that during that section of the water line, you have contamination by biofilm or any sediments. And you can, have a look using this inspection camera and really inspect the water line. So the next disinfectant we are going to talk about is chlorine dioxide. You can use a kit to measure its residuals. If you are using chlorine dioxide to treat your water, then you are going to use this kit. So the target chlorine dioxide levels, it should be up to 5 ppm total chlorine dioxide. But if your kit is measuring free chlorine dioxide, the free chlorine dioxide level should be around 1 ppm during the disease outbreak. And if you are using chlorine to disinfect your water, then you can measure total chlorine or free chlorine in your water line. So there are some test strips or some kits, but always pay attention to the label or manual guide to see what type of chlorine it is measuring, if it is total or free chlorine. For example, these test strips can measure total chlorine and free chlorine, but some of them, for example, looking at this kit, it can only measure total chlorine. Or for example, this one here, you can see it only tests free chlorine. But overall, we need to measure total chlorine, free chlorine, and ORP, all of them together. So total chlorine should be 8 to 10 ppm at the end of the water line, and free chlorine 3 to 6 ppm, and ORP should be more than 650 millivolt. ORP stands for oxidation reduction potential. So it shows the killing power of your water. So if you have heavy metals and minerals in your water, it's going to reduce the ORP level, which is not good. But overall, if your ORP level is above 500 millivolts all the way to 750 millivolts, it shows that your water has a good disinfection potential. And there is a tool like this that can measure pH and also ORP.